Experience a new era of smart cleaning with the Doxpro Robotics automatic vacuum cleaner, powered by advanced LiDAR mapping. As electronics students, we aim to ease our family's cleaning burden. Our DIY project, the automatic vacuum cleaner, is built to assist at home with smart, self-made tech. Our project focuses on creating an automatic floor cleaner using LiDAR technology to achieve accurate and efficient cleaning. We've integrated smart obstacle detection to avoid collisions and ensure safe movement around the house. Additionally, we aim to improve user convenience with features like automated scheduling and remote control, making daily cleaning hassle-free. This is the block diagram of our automatic vacuum cleaner. The battery supplies power to the entire setup. At the center, the Arduino UNO works as the main controller. It takes input from the sensor, which helps in detecting nearby obstacles. Based on the sensor data, the Arduino sends commands to the motor driver. This driver controls the 4 BO motors, which move the cleaner in different directions. This combination ensures smooth movement and intelligent obstacle avoidance. Let's have a look at the flowchart. The process starts by initializing the system, where all components like the Arduino, LiDAR sensor, and motors are activated. The LiDAR sensor then measures the distance to detect any obstacles in the path. If an obstacle is found, the cleaner stops and changes direction to avoid it. If the path is clear, it moves forward continuously. While moving, the suction mechanism is activated to collect dust and debris. The collected waste is then stored in a built-in container, completing the cleaning cycle. Project setup. Let's take a look at all the key components of our automatic vacuum cleaner. First, we have the Arduino UNO, the central microcontroller that handles all commands and logic of the system. This is the servo motor. It rotates to a specific angle as directed by the Arduino, useful for precise movement. This is the VL53L0X LiDAR sensor, responsible for detecting obstacles by measuring the distance to nearby objects. The lithium-ion battery powers the entire circuit, including motors and electronics. At the center, we have the suction motor, which creates airflow to pull in dust and dirt. Next is the L293D motor driver, which receives signals from the Arduino and drives the motors in both forward and reverse directions. Here we have a button to control the power input to the system. In the middle of the system, we have used a plastic pipe to transfer the dust and debris to the container, present at the corner of the system. A hard plastic nozzle is used to collect the dust and debris from the floor, which is connected to the pipe. The sensor used in our system is the VL53L0X LiDAR sensor. It works by emitting an invisible laser beam and measuring the time it takes to reflect back, giving accurate distance readings. This data helps the robot detect nearby obstacles in real time. The Arduino processes this information and makes decisions like stopping or changing direction, ensuring smooth and intelligent navigation. It might sometimes not work perfectly, but will work surely. The vacuum system uses a suction motor to create airflow, pulling in dust and debris from the floor. The collected waste is then stored in a built-in dust container, making cleaning automatic and efficient.